Questions 11 through 20 of the 1998 Grade 11 Fermat Math Contest is what I will discuss in this video. The number of solutions xy of the equation 3x plus y equals 100, where x and y are positive integers, is. So 3x plus y equals 100 is our formula. And best thing to do is just make a table for x and y. And let's see what we get. So x and y are positive integers. So if I'm going to start somewhere, let's say I start with x, I can only start with 1 and go up from there, 2, 3, and so on. So let's see. When x is 1, y is 97. And you just get that by plugging it into here. You can even do that in your head really quickly. It would just be 100 minus 3. When x is 2, you get 94. When x is 3, you'd get 91, and so on. And when I keep going like this, eventually I'll get to 33, and y is 1. After that, there's no more solutions where x and y are both positive, because if I put 34 for x, you would get 3 times 34 plus y is 100. Y is 100 minus 102, and y is therefore negative 2. And since y is negative, that's not a possible solution for our conditions. So this is no good. So the only possible solutions are those ones, and there are 33 of them, from 1 to 33. So the answer for 11 is A. In the diagram, the value of y is. All right, let's draw this a little bit bigger. All right, let's start filling in the information. So this point here is 8, 0. And this point here is 13y. Like that. So that means that if we would drop a perpendicular down here, this is 13 on the x-axis. So therefore, from here to here is 13 minus 8, which would be 5, the length. And I've drawn a little right triangle for myself. This angle in here is 30 degrees. And therefore, this angle would be 60, right? Because the sum of the angles of a triangle are always 180, and this is 90. That's what that box means. So what do they want in this question? The value of y. All right? So y is the coordinate on the y-axis. So therefore, y represents this length right there. Okay, so how do we do this? Well, there was something called a 30, 60, 90 triangle. So anytime you have a triangle that has the angles 30, 60, and 90, the sides will have a special ratio, 1, 2, and root 3. That is not the length of the sides necessarily, but the ratio of the sides. Okay, remember that. That's going to come up again and again during math contests. So we can use that and compare it to our triangle. So what do we have? We've got y over 5 is equal to 1 over root 3, because that is the ratio. So if you solve for this, you get root 3y is equal to 5, and therefore 5 over root 3 will be equal to y. So 5 over root 3 is choice B for number 12. 3-digit integers are formed using only the digit 1 or 2. The sum of all such integers formed is. All right, so we've got integers that are 3 digits like this. And you make these digits with just 1s and 2's. That's it. Those are the only digits you can use. So if we do that, how many are we going to get first of all, just to make it a little bit clearer? Well, if you have 3 digits, for the first digit, you can only have 2 choices, either a 1 or a 2. So there's 2 choices. For the second, again, either a 1 or a 2, 2 choices. And for the third, also 2 choices. So you multiply this and you'll get 8. So there's 8 such numbers. So manually, I've got to come up with 8 such numbers. Well, 111, 112, 121, 211, 122, 212, 221, and 222. I think this is all of them. And then you just add them all up. And if you add them, you'll get 1, 3, 3, 2. That's the sum of all such integers formed. So that would be choice A. 3 straight lines, L1, L2, and L3, have slopes half, third, and a quarter, respectively. All 3 lines have the same y-intercept. If the sum of the x-intercepts of the 3 lines is 36, then the y-intercept is. All right, so we'll have to write out a few equations. And remember, the equation of a line is of the form y equals mx plus b, where m is the slope and b is the y-intercept. So I'm going to put this information into 3 equations. The first one is y1 for the first line, L1. And we've got half for the slope, x1 plus b1, because we don't know what these are yet. For L2, it would be y2 is 1/3 x1 plus b2. And for line 3, it would be y3 is 1/4 x1 x3 plus b3, like that, okay? And when we set these to 0, we will get the x-intercepts. All right, so let's do that. Let's set all of these to 0 to get the x-intercept. So we got 0 is equal to 1/2 x1 plus b1. 0 is equal to 1/3 x2 plus b2. And 0 is equal to 1/4 x3 plus b3. Is there anything in this question that's going to help us? This point here, all 3 lines have the same y-intercept. Remember, this is the y-intercept. So all 3 lines have the same y-intercept, so that means b1, b2, and b3 are all the same. That's what that means. So we can just write this in terms of just one variable and just call it b. We don't need to put b1, b2, b3 because they're all the same. So that's going to help us. All right, let's keep going here. So for the first one here, that looks like if we multiply everything, or if we bring everything to one side, we'll get minus b is equal to x1 over 2. And therefore, x1 is equal to minus 2b. All right. For the second one, same kind of story here. We've got minus b. Sorry, this was 1/3 and this is 1/4. You just have to copy those. So minus b is equal to x2 over 3. And therefore, x2 is equal to minus 3b, like that. And then the last one, the third one, we have minus b is equal to x3 over 4. And therefore, x3 is equal to minus 4b, like that. Okay? Now, these are our x-intercepts. And the question tells us that the x-intercepts, if you go back to the question, the sum of the x-intercepts is 36. So that means that x1 plus x2 plus x3 is 36. Now we can plug in the values in terms of b to solve for b. And minus 2, minus 3, minus 4 is minus 9. b equals 36, and therefore b is equal to negative 4. Now, what is the question asking us at the very end? What is the y-intercept? Well, the y-intercept, if you recall, is this guy, b, and for us, b is equal to negative 4. So the answer for this would be 14C. X is between minus 2 and 5, y is between minus 3 and 7, and z is between 4 and 8. W is equal to x, y minus z. What is the smallest value of w? Okay, so another one of those extreme case scenario questions. So if we want this to be the smallest value possible, we want this to be the smallest, and we want this to be the largest. And that way we will be able to figure out the smallest value of w. Well, z being the largest, I think that's the easier one to figure out. So what's the largest possible value of z? Well, z is between 4 and 8, so the largest value of z is 8. Now, this is a little bit more tricky. xy, we want the smallest possible value of xy. Okay. Well, x is between minus 2 and 5 inclusive, and y is between minus 3 and 7 inclusive. So you just have to kind of do a little bit of trial and error and see what's the smallest possible value of xy that I can get with these numbers as possible choices. And the answer would be 5 for x and negative 3 for y, because that would become negative 15. All right? Any other possible choices would give you a number that is greater than negative 15. So therefore, this is going to be negative 15 minus 8, which is minus 23. And that would be choice E. If 7 to the power of p plus 4 times 5 to the power of q times 2 to the power of 3 is a perfect cube, where p and q are positive integers, the smallest possible value of p plus q is. All right, let's write this out. 7 to p plus 4 multiplied by 5 to the q multiplied by 2 to the power of 3. The only way this can be a perfect cube is if the exponents are divisible by 3. All right, to be a perfect cube. And the exponent of the number 2 is already divisible by 3, so that's great. So we've got to make q and p plus 4 also divisible by 3, and we have to do it by choosing the smallest possible values. Well, for q, what comes to mind is q equal to 3. And for p plus 4, let's see, if p was 1, you would get 5, and 5 is not divisible by 3. But if p was 2, you would get 6, and 6 is indeed divisible by 3. So therefore, if p is 2 and q is 3, we would get 7 to the power of 2 plus 4, 5 to the power of 3, and 2 to the power of 3. And this is indeed a perfect cube, like that. And just in case you're not convinced that it's a perfect cube, you can take the cube root of both sides, and the cube root of this would be the cube root of 7 to the power of 6, 5 to the power of 3, and 2 to the power of 3. And the cube root of that, of course, is 7 squared, 5, and 2, multiplying like that. And that is an integer, and therefore this was a perfect cube. So in the end, they're asking you what is p plus q. P was 2, q was 3, so therefore p plus q is 5. So 16 is A. Using only digits 1, 2, 3, 4, and 5, a sequence is created as follows: 1, 1, 2 2s, 3 3s, 4 4s, 5 5s, 6 6s, 7 7s, 7 2s, and so on. So the sequence appears as this. So you can see there's 1 1, 2 2s, 3 3s, 4 4s, 5 5s, and then 6 1s, and then there's going to be 7 2s, and so on. The 100th digit in the sequence is. All right, so for the digit 1, there's going to be 2 of them. Sorry, there's going to be 1 of them initially. For the digit 2, there's going to be 2. For the digit 3, there's going to be 3, like that. For the digit 4, there's going to be 4, just like what they've written here. Okay? For 5, there'll be 5, 5, 5, 5, like that. For 6, 6 of them, and so on. So you understand what's happening here. Oops, there's not going to be 6s, don't make that mistake. There's going to be 1s. 1, 1, 1, 1, 1, 1. Okay? And then for 7, there'll be 2s, like that. And then just keeps on going like that. For 8, there will be 3s, and there will be 8 of them, and so on. So what they're asking for is the 100th digit. So this is the first one, second one, third one, fourth one, fifth one, sixth one. And then they're saying, when you get to 100, what number is that? Okay. So it looks like you're basically adding numbers that are consecutive. 1, 2, 3, 4, 5, 6, and so on. So 1 plus 2 plus 3 plus 4, all the way up to some number, n, let's say, is eventually going to get close to 100 because we're interested in the 100th digit. Now, there is a formula that's very helpful to use whenever you have the sum of consecutive numbers. If you have the sum of consecutive numbers 1 plus 2 plus 3 and so on all the way up to n, the sum is equal to n times n plus 1 over 2. And this is helpful, especially if the numbers are very, very large. If you have 1 plus 2 all the way up to 6,000, you're not going to sit there and add 1 plus 2 plus 3 plus 4. You'll just use this. So let's put this into this formula and see what we get. So if this is n times n plus 1 over 2, and that's equal to 100, we're sufficiently close, then we'll have n times n plus 1 is equal to 200. Now, you don't need to solve this by making it into a quadratic equation and using the quadratic formula. That would be a little too cumbersome and unnecessary. But what you can do is sort of look at this and say, n times n plus 1 is sort of like n times n, right? It's sort of like n times n, because n plus 1 is not that much different. So if n times n is 200, approximately what is n? And you can do that by taking the square root of 200, and that is about 14 point something. So n is most likely close to 14. So that essentially means that we're going to have 1 plus 2 plus 3 plus 4 like that. And when you add all these up, you will get close to 100. And if you do add these up, you'll notice that 1 plus 2 plus 3 all the way up to 13 gives you 91. And you can, of course, verify that with this formula. 13 times 14 divided by 2 is 13 times 7, which is indeed 91. So what does that mean? It means that for the 1, there was a 1, there was 2 2s, there was 3 3s, there was 4 4s, 5 5s, and be careful, for 6, it's 6 1s, and then 7 2s, right? And then for 8, there's 3s. For 9, there's 4s. There was 5 here, 10 of them. And then for 11, we get back to 1, 11 1s. For 12, there was 2s, 12 2s. And for 13, 13 3s. And then we get to the final 9 numbers because we want the 100th digit. So we've got, if we write them over here, 92, 93, 94, 95, 96, 97, 98, 99, and the 100th digit. And these are going to be 4s, correct? Because right before it, you had 13 3s. So the 100th digit is going to be a 4. So the answer here is D. Q is the point of intersection of the diagonals of one face of a cube whose edges have length 2 units. The length of QR is. All right, let's draw this out a little bit bigger. All right, so here is our cube, and we are going to draw some diagonals right here, and that point is Q in the intersection of those diagonals right there, this point right here. And then they want us to figure out QR, so this distance right here. They want us to figure out QR, where that vertex is R. Okay, so the best way to approach this is to create for yourself a right triangle by drawing a line that's perpendicular to the base there and a line from R to that point. And we can label these P, let's say, and call this S, this vertex right there. And then this is a right triangle. And therefore, we can create a relationship with the Pythagorean Theorem, and that would be QP squared plus PR squared equals QR squared. And QR is what they want us to figure out. So if we can figure out QP and PR, we will be able to solve this question. So now let's draw this part of the diagram, but let's draw it flat. So what I did was I just drew it sort of head on, and there's your diagonals, and this is Q. Now this question doesn't really give us much information. They only tell us that the length of the cube sides is 2. So that's 2, that's 2, that's 2, like that. But remember, we drew a perpendicular, and if you draw a perpendicular from Q down to the bottom like that, then that essentially means that you've broken this up into half. So this is 1 and this is 1. And similarly, since this line is from the center, it's basically going to be half of 2. So this will also be 1. So this point we had called P, therefore QP is 1. So QP is 1. All right, so we've got half of what we need. Now we need to figure out PR. Well, PR is right here. Now, how do we figure out PR? Well, concentrate on this triangle right here. Concentrate on triangle PRS. So I'll draw that out a little bit bigger here, like that. So this is P, this is R, and this is S. And we know that RS is just a side of the cube, so that's 2. And PS right here, we know, is 1 because it's a half of the side. So therefore, RP we can figure out from Pythagoras. We've got 2 squared plus 1 squared, and therefore this is 5. So RP would be the square root of 5. Or PR. RP, PR, same thing. So PR is the square root of 5. So now we can solve for this. So we got QP squared, which is 1 squared. PR squared, which is the root of 5 squared, is QR squared. So we've got 1 plus 5 is QR squared. QR is 6. QR squared, that is. And therefore, finally, QR is equal to the square root of 6. And that would be choice E. The square ABCD has a length of 14 on the sides. A circle is drawn through AD, right here, so that it is tangent to this BC line, tangent right here, as shown. What is the radius of this circle? Okay, let's draw this out a little bit bigger. All right, so let's start labeling these now. We've got A up here, we've got B here, C and D, and I'm going to call this the center of the circle right here, and I will need to draw some lines to represent the radius. So I think this line is sufficient. That will be the radius of the circle. And if you draw a line from the center to the point of tangency, that's also the radius. So we can label those R and R. And what else do we know? We know that the length of the cube is 14. So from here to here is 14. From here to here is 14. Okay? The length of the square, rather. It's not a cube. And then since this radius cuts BC in half, from here to here would be 7, and from here to here is 7. And therefore, if I drew a line from the center of the circle to the top of the square, that would also be 7. And from here to here is R. It's just the same as this distance. And therefore, from here to here is going to be 14 minus R. All right? So hopefully that was pretty clear. Now this triangle is a right triangle, and you can then use Pythagoras to solve for R. So in this triangle right here, we've got 14 minus R squared plus 7 squared is equal to R squared. So if you multiply this out, we've got 196 minus 28R plus R squared plus 49 is equal to R squared. So let's see, 196 plus 49, and take the 28 over to the other side, the 28R. So we've got 245 equal to 28R. So R is equal to 245 over 28. And therefore R is 8.75. All right. So 19, the answer is B. A deck of cards is numbered from 1 to 100. Each card has the same number printed on both sides. One side of the card is red and the other side is yellow. Barsby places all the cards red side up on a table. He first turns over every card that has a number divisible by 2. He then examines all the cards and turns over every card that has a number divisible by 3. How many cards have the red side up when bars B is finished? Okay, so first let's understand this question before we tackle it. So you've got a bunch of cards, and on one side of the card, it's red. And on the opposite side, it will be yellow. So if you were to flip the card over on the other side, it's yellow. And then every card has a number on it. 1, 2, 3, all the way up to 100. So initially, when he places the cards on the table, he places them all red side up, like that. Okay? Like that. All the way, and so on. All the way, he just keeps on going, all the way up to 100. So these are now all reds. Red, 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 like that. And they, of course, have numbers on them. They have the numbers 1, 2, 3, 4, 5, and so on. Then he turns over every card that is a number divisible by 2. So that means he's flipping over any number that's divisible by 2. So 2, 4, and 6. So initially you have 100 cards that are all red. So then he flips over the ones that are divisible by 2. So what happens when you do that is that all the numbers that are even get flipped. So this becomes a yellow, this becomes a yellow, this becomes a yellow, and so on. And the numbers, therefore, on the cards are 2, 4, 6, and so on, dot, 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 all the way up to 100. And then all the other cards remain the same, because those had numbers that are not divisible by 2. So those remain exactly the way they are. So at this point, what's our count? Our count is over here. We've got all the cards divisible by 2 were flipped, so that's half of the cards. So that means 50 cards are now red, and the other 50 are yellow. All right? And then the final step, what he does is he examines all the cards, and then now he turns over every card that has a number divisible by 3. So at this point, he's going to do the following. He's going to flip over every card divisible by 3. So cards that have 3, 6, 9, 12, 15, 18, and so on, all the way up to the largest number that's divisible by 3, which would be 99. Because the largest card is 100, and 100 is not divisible by 3. All right, so these are the cards he will now flip over. But we need to break this set into 2 sets, odd and even. And that's important. Why? Because currently the red cards have odd numbers on them, and the yellow cards have even numbers on them. So how many odd numbers are there in this set? Well, first of all, how many are in the set? Well, there's 33. And you can easily do that by doing 99 divided by 3. The number of odd in this set are 17. And the number of even cards in this set would be 16. Okay? And you can just write them out. So for example, even is 6, 12, 18, and so on. And then odd, of course, is 3, 9, 15, 21, and so on. So if we are flipping the odds, then what happens? Well, initially you had 50 red cards that had odd numbers on them, and you're going to flip 17 of them. So when you flip 17, 33 remain as they are, and the other 17 that you flipped become yellow. Okay? And then for the cards that are yellow, if you're going to flip 16 of those, 34 will remain as is, and the other 16 now flip and become red. So this is our scenario. And what they want you to figure out is how many cards have red side up when Barsby is finished. So how many are red in total at the very end? Well, we have 33 red over here, and you have 16 red over here. So the total red is 33 plus 16, which is 49. And therefore 49 is choice E.